we want to work an example problem that involves a whole bunch of forces going in multiple directions with a block that's accelerating. And so now we're moving out of equilibrium and we're moving into accelerated motion. Now remember, that just means the net force is not zero and the block will move. Not only will it move, it will speed up or slow down. So this says a 40 kilogram block, so there it is pulled by a force F, here's F, at a 25-degree angle, there's my angle. The coefficient of kinetic friction is 0.44, so I wrote that down, and the block accelerates to the right at 1.4 meters per second per second. Find the magnitude of F. Alright, so I know the acceleration in x is 1.44, and since I'm calling that x, I'm going to go ahead and I'm going to draw my reference frame in here. And so here's x, it's positive. Here's y, it's positive. Remember, those are at right angles to each other. Now, all I've got to do is go through and plug in everything I know and solve for everything I don't. So I've got my force due to gravity labeled Fg. I've got my force that's pulling F. I've got the normal force Fn. You'll notice I drew it smaller than Fg because some of this force is going to counteract it. And I've got my friction, Fk. And let's see if we can deal with any of this. First thing I want to notice is I do know something about x. So I'm going to start in the x direction. Okay. So the net force in x, let's see, let's find all the forces that act in x. I have this force, the component of the pull force that acts in the x direction. Okay? And so this is F cosine, right, the adjacent side, 25. And I'm actually going to go ahead and find what the cosine of 25 is. So the cosine of 25 degrees is 0.91. Alright, so this is equal to F times 0.91. This is F times the sine of 25, because it's the, this is opposite, I guess I don't really have to do this, but I'm going to start it. Right? So sine 25 is 0.42. So this equals F times 0.42. Alright, back to what I was doing. The net force in x is equal to this force, F cosine 25, so F times 0.91, plus Fk, and that has to equal the mass times the acceleration. The mass is 40 kilograms. The acceleration in x is 1.4 meters per second per second. Okay, so I have that information, but now I'm stuck because I have, here's a force that I don't know, here's a force that I don't know, and here's 40 times 1.4. Okay, so that is a number I can deal with, so let's go a little bit further, because I actually know a little bit about Fk. Fk is actually equal to the normal force, Fn, times the coefficient of friction, 0.44. So I can put that in there, except I'm going to go ahead and I'm going to change this negative because the friction is pulling the other way. So this is actually going to give me an absolute value for Fk. So I'm going to change this to negative. So I got the net force in x is equal to 0.91 F minus the normal force times 0.44. Right? And the reason it went negative, the normal force is positive, but the frictional force is negative, so there's opposite. So I had that sign in there, equals, and then I have 40 times 0.14, or not 0.14, 1.4, 56. Alright, but I'm still stuck because I still don't know the normal force. So I'm going to go ahead and I'm going to circle that equation. I'm going to leave it there for a minute. I don't know what else to do. And now I'm going to go to the y direction. The net force in y is equal to the normal force, Fn, plus Fg, plus this force in y, Fy, which is F times 0.42. And this, I'm going to go ahead and I'm going to assume that this equals 0. I'm going to assume that this force is not big enough to accelerate this thing up off the ground. So the normal force sums with all the other things, we're going to get to 0. Now, I can start plugging in things I do know, because I do know Fg is equal to mass, 40, times the acceleration due to gravity, which is negative 9.8. So 40 times 9.8 is negative 392. So I do know the force due to gravity is negative 392 newtons. So let's see. Rewrite this and I get the normal force minus 392 plus 0.42 F equals 0. Alright, and now it looks like I'm stuck again because now I have another equation with two unknowns in it. except I can actually deal with this one because I can take and solve the normal force here and plug it in there. So I'm going to find the normal force. The normal force is equal to, I'm going to add that 392 over, minus 0.42F. Alright, so now I have a value for the normal force. It's not solved because I have an unknown in it, but I can sub that in here where I have the normal force. So now, doing that, I'm going to take the net force in X equals 0.91 times F minus, and now this is where my substitution comes in. And I'm going to put this whole thing in parentheses, 392 minus 0.42 F, and then I've got to multiply that whole thing by that 0.44. That was my coefficient of friction. Alright, so I'm going to distribute this negative through first, so I'm going to get 0.91 F. Actually, I can distribute the negative 0.44 through there, but so 0.91 F, 392 times negative 0.44 is 172.48 negative. So minus 172.48, and then a negative negative is positive, and 0.42 times 0.44 gives me 0.1848 F, and this, according to my equation up here, is equal to 56. Alright, so then I can combine my like terms, 0.91 plus 0.1848. So 0.91 plus 0.1848 is 1.095. So 1.095 F equals 56, and I'm going to add this over plus 172.48. So 172.48 plus 56 equals 228.48. 228.48 newtons. Now I can take this equation and find F. So 228.48 equals 1.095 F. Divide both sides of this by 1.095, and I get force F equals 208.66 newtons. Alright, so that problem was a little bit tricky because there was a lot of unknown information and I had to use a simultaneous equation to do it. I solved one and subbed it into the other, but the keys to doing this equation are right here. I split this up into the x direction and I found what I knew about it. I knew the net force in x had to cause some acceleration, which is ma, and I knew the net force in y wasn't going to cause acceleration, or at least I assumed it wasn't. Now I guess I could actually check my assumption. If the force is 208.66 newtons, that means, well, gravity's pulling down at almost 400 newtons, so yeah, we're not anywhere close, so that was a good assumption. Right? So just remember, when you're doing things in multiple directions that have forces acting in multiple directions, you need to account for that. You need to do your Newton's second law in the x direction and Newton's second law in the y direction, and then it's just a matter of doing the math.